Hi everyone, my name is Dima Hassan. I'm going to be talking about the data warehouses, specifically about the Snowflake data databases. Okay. Next. Hi everybody, my name is Dima Hassan. I'm going to be talking about Hi everybody, my name is Dima Hassan. I'm going to be talking about the data warehouses, specifically about the Snowflake database. Uh, in in the very big companies like Netflix and um, like for example Facebook, they need to store a very huge amount of data about the customers so they can help the customer. And for that, they want to use the data warehouses, which basically in the era of big data, organizations are forced with the challenge of effectively managing and analyzing vast amounts of information from various sources. A key concept that has emerged to address this challenge is data warehouses. While they serve the purpose of data storage and analysis, data warehouses are designed to store structured data that has been transformed and organized for specific business intelligence and reporting purposes. What is the data warehouses? It's a structured, purpose-built data repository designed to support business intelligence and reporting. A data warehouse is an integrated, subject-oriented, time-variant, and non-volatile collection of data, specifically organized to provide efficient and effective access for data analysis and decision making. The key defining characteristics of the data warehouses is its focus on structured data that has been extracted from various operational systems and transformed and loaded into a consistent optimized schema. This process known as extract, transform, and load, which ensures the data is clean and standardized, ready. And the warehouse is organized into dimensional models, such as the star schemas, or what we're going to be talking about in our video, which is the snowflake schemas, which provide a clear separation between fact tables and dimension tables, enabling faster and more efficient querying. The data warehouses are primarily designed to support strategic decision making, providing a comprehensive view of an organization's performance, trends, and key performance indicators. They are typically used for tasks such as sales analysis, customer segmentation, and financial reporting, and operational optimizing. The structured nature of the data warehouses make it easier to generate predefined reports, dashboards, and visualizations, allowing business users to quickly extract insights and make informed decisions. So now I'm going to be talking about the snowflakes. What is a snowflake and why do we use the snowflake? The snowflake is fully managed cloud-based data warehouse solution. It's fully a cloud data platform and data storage and data analytic solution, and it's a software as a service platform to load and analyze the massive data volumes. And as I just said, it's a cloud-based data warehouse platform that has emerged as a leading solution for organizations looking to effectively manage and analyze their growing data assets, just like we've mentioned Netflix or Facebook, for example, and it's built on a unique cloud native architecture. We're going to be explaining the architecture in the next slides, and it offers a seamless and scalable data storage and analytics experience, addressing many of the challenges associated with traditional on premises data and warehousing solutions. At the core of Snowflake's capabilities, it's a parented data sharing feature, which allows users to securely share and access data across organizational boundaries without the need for complex data replication or ETL processes. As we've mentioned, it's totally on the cloud, so it provides a very secure data sharing from the user. And about its architecture, it's designed to be highly scalable, allowing users to instantly provision additional compute and store resources as needed to handle growing data volumes and increasingly complex analytical workloads. This helps the organization to avoid the traditional challenge of over provisioning or the under provisioning resources, leading to more efficient and cost effective data management. Why do we choose the Snowflake databases over other uh, types of databases? It goes to its performance, and it has a SQL support and scalability and data storage, and it requires a zero maintenance since it's on the cloud. You don't have to do any maintenance of the servers or anything that handles the big data. And it's fast analysis and data sharing. As we just said, it's providing a safe data sharing, and it's on demand pricing. Um, like just you can take it for like as much as you need time. You don't have to rent it from the cloud for a longer time. You just rent it for an hour or two, or a day or two, or as much as you just need. You don't have to pay extra. And it has a semi-structured architecture we'll be talking about in a minute, and it provides a very high secure data sharing and time traveling and the cloning. And now for the snowflake schema, uh, it looks like a snowflake, an actual snowflake. That's why where it gets where it got its name, because it looks like the snowflake, the schema of the database. And now I'm going to be talking about the Snowflake multi-cluster shared data architecture, which basically is um, a three layers, as you can see, like basic three layers. As the first layer is the cloud services, which can be Amazon or Google or anything that provides the Snowflake database. And the cloud services provides the authentication and access control, the infrastructure manager and the optimizer, transaction manager, and security. And basically, the cloud services has the metadata, and the cloud services is called the brain of the Snowflake. We're going to be talking about why in the next slide. And the second layer, which the compute resources, which basically is a couple of virtual warehouses, uh, and we're gonna be talking about the use of these virtual warehouses and why do we use them, why do we need them, basically. And finally, the storage resources layer. And I'm gonna be talking about the architecture of the Snowflake, which basically starts from the data sources. Uh, the data sources can be any kind of data files, Excel sheet, or a JSON file, or a text file. It can be any type of these, or it can be RDBMS, on-premises data, or it can also be a cloud databases. So the data sources can be any kind of these. You shouldn't be worrying about that as a user. The cloud must handle any type of these data files. So basically, the next thing you have to be like to rent one of these clouds. It could be the AWS or the GCP or the Azure cloud, any of them that supports the Snowflake database. And it basically takes the data sources and it do the ETL, as we just said, that does extract, transform, and load the data into the S3 bucket, which is basically a simple storage service provided by Amazon. For example, this cloud is from Amazon. And then, as you can see, after the S3, you have these are the data warehouses, the virtual warehouses, let's say. And there are 4 ways to transform the data from the data sources into the Snowflake tables. The first one is the put command into the internal stage uh, via the virtual warehouse, or the copy command via the external stage and the virtual warehouse, or the external table, which is the third method, via the virtual warehouses also. And finally, the snowpipe command, which also needs a virtual warehouse to transform the data into the Snowflake environment. And then it will be staging tables or a core reporting tables will be transformed to data consumers, which can be any of these data consumers. Finally, I'm going to be explaining the Snowflake architecture in detail now. Um, the Snowflake does first thing it does, it breaks the table into multiple smaller partitions. As we can see, the table on the left is divided into these three partitions, and these partitions are called micro partitions, which is not more than 500 megabytes in size, like the maximum size. Each table partition is between 50 to 500 megabytes of uncompressed data. The next thing that they do is they reorganize the data in each partition, make the columnar, which is the column values in the partition are stored together. The next step is compress each column, and that's that values individually. And they add a header, as you can see, for each partition. It has a header like this one in here, and these headers, uh, the header contains the offset and the length of each column, stored within the micro partition in these headers. And they also store the metadata, some other metadata information in the header, but the column offsets are the most critical information for us. Understand grade pattern. So that's why we need the header for each partition, so we can reach the column we need the data from using the offset of each column. And the micro partitions are stored in the S3, as we just saw in the previous slide. S3 are immutable files, and a lot of additional metadata and statistics about these micro partitions is maintained in the Snowflake metadata layer in here in the service layer. And that's why they call the service layer the brain of the Snowflake. When you fire a SQL query, the Snowflake would know which table and which column do you want to read using the offset, as we've mentioned, which micro-partition files um, in the S3 belong to the desired table. So they know which file is to read, but instead of reading a complete file, they first read the header and then they read only those columns which you want to read. And this is possible because of the S3 APIs, which provided by Amazon, for example, they allow them to read a part of the file. And here's a simple code of using the Snowflake architecture. Most of the time, the code is usually more complicated than this, but just for the simple example, I'm explaining using this small code. And for the desired data, this allows the first level of partition pruning, and targets only those micro partitions where the desired data is stored. In the next step, they first read the micro partition header and they only read the desired column using the offset. And this allows the second level of column pruning and minimizing the overall I/O for the SQL. And if you have any questions, leave it on the comment section below. Thank you for watching.